ready, we can start the session with you.
Yeah, we can start.
Sure. So I'll just stop sharing.
So can someone confirm if my screen is visible?
Yes, Atharva.
Okay, so we'll go ahead and start. So again, I welcome you to RattleSnake, an automation workshop by WnCC and Institute Technical Council as a part of PG Tech Weekend. So yeah, those were pretty interesting responses that you guys gave. But for the scope of this session, we'll mostly be covering the libraries for data analysis, automation, and image processing as follows. So for data analysis, we'll be using NumPy, SciPy. These are the libraries that mostly are used for advanced functions that you might need for completing your assignments. Matplotlib and Seaborn are used for data visualization, like plotting graphs that includes 2D and 3D, and a huge variety of them. We'll be seeing them in today's session. Then, in terms of automation and web scraping, we have Selenium. In image processing, we have OpenCV. So this is a brief introduction to the libraries that we are going to cover. Now we'll go ahead and jump right into the installation part. Uh, I hope everyone has gone through the prerequisites of Python and virtual env. So it's expected that you know how to install libraries. So this is the command that you will be using to install the libraries required for the data analysis part. Seaborn is a high level library, so it will cover all the dependencies that are going to be required. So I'll just show in brief how to do it. So firstly, I'll show in the Linux terminal. So you're expected to install Python. So after that step, you can just go ahead and create a virtual environment. So for creating a virtual environment, you do a Python m. Okay, so this will create your virtual environment. Now, why virtual environment is necessary? So it is quite covered in the basics, but this helps in solving the dependencies issue. Like some of your projects might require a different version of the packages, and so putting them into a virtual environment is useful in such cases. Okay, so I'll go ahead and okay. So now we are in the virtual environment. So whatever you're going to do, it's better to do it here. So now we'll go ahead and install the libraries. The command is pip install Seaborn. So if you want to follow along with the hands-on part of today's session, you can start with this for now. And when we come to the hands-on part, you can code here itself. Okay, so it might take some time downloading. Since I've already downloaded it, it got installed quickly. A similar thing can be done if you're using Windows on the command prompt. So the first command is same for both. Okay, and after running the script, you are into the virtual environment. Now again, you can do a pip install Seaborn. So yeah, repeating again. So get this done now so that you can follow in the hands-on session. Okay, continue. Okay, so the first library we are going to cover is NumPy. The basic use of NumPy is creating and manipulating multi-dimensional arrays. It has wide applications in terms of linear algebra and matrix computations. So NumPy includes functions that can operate over these arrays. We'll be covering some of those functions here, and the more advanced functions you can always refer to the links that are going to be provided. Okay, so these are some of the packages included in the NumPy library. So there is the linear algebra package, there is a matrix package, a random number generation package, the Fourier transforms, dual, emath, and there are much more. That's for you to explore. Whichever you need for anything related to arrays can be found here. So we'll start with the basics. So ND array is the object that is used in NumPy to do all the computations. So the very first attribute that you are going to see is the dimension of the array. In NumPy, the arrays, the dimension of the arrays are called axes. So each of these axes, you'll see the dimensions using this command. Then the shape of the array, this will be a tuple of the number of rows, columns, and other dimensions that are there in the array. Then the size, this is the total number of elements. This will basically be the multiplication of all the elements given from the shape command. Then you have the data type. So the usual data types are obviously supported. Additionally, NumPy also provides its own NumPy.int32, int16, and float64 data types. There are much more, but these are the ones which are mainly used. The item size gives the size in bytes occupied by the data type. So it will, for example, for float64, it will be 8 bytes, or for complex 32, it will be 4 bytes. Okay, so the very basic thing, now that you have installed the library, the first thing you are going to do is import the library. So NP is the common shorthand used for importing NumPy. So this is the first line which will be included in all of your NumPy codes, and then you can create an array just like you would create a 1D array or a list in normal Python. So you call np.array, and then you uh, give the array in square brackets. So each dimension can be separated by a square bracket. Okay, so for example, this is a 2 by 3 by 4 dimensional array. All right. So now for specialized arrays, here are some examples. You can create an array with mixed data types. So it will automatically in it will automatically include the biggest data type that is being covered. So in this case, a float. You can also specify the data type while creating the array. Like in this example, we are creating an array of the complex data type. So it will extrapolate the values that are given to a complex array. Then for special cases, you might sometimes need an array of zeros or ones. So those can be accessed by the np.zeros command, and the arguments are is a list of the dimensions that you want. Then similarly for the ones, you can specify a data type in creating any arrays. Now these are some more types of arrays, specialized arrays that you might need. So a range will give an array in the range from the first argument to the second argument, separated by the number given in the third argument. Okay, so like if you give this command, it will give numbers from 10 to 30 with a difference of 5. And similarly, the difference or the start and end points can also be float arguments. So it will give out the results accordingly. Then NumPy also includes some constants like say pi, which can be used. The linspace is another command. It is similar to arrange, but it takes the two arguments which are start and the third argument is the number of elements you want instead of the difference between the elements. So the number of elements is 9, so it will give elements from 0 to 2 in both inclusive, and the total number of elements will be 9. And you can do a more complex kind of thing by giving the arguments as anything like this is 2 pi and you're putting 100 elements into this array, and then you can further use this to create a sine wave, and then you can plot it as we are going to see with the Matplotlib. Okay, so the next thing we are going to cover is basic array operations. So we can start with creating arrays, and then we can do the basic operations like array subtraction, array addition, or multiplication or exponentiation. Multiplication and exponentiation that are used, they will do an element wise operation. So like b star star 2 is basically b raised to 2. So it will give an array with each element squared. Similarly for scalar multiplication, another operation is creating a Boolean array which satisfies the conditions given. So our original array had these 4 elements, out of which only the first to satisfy the condition less than 35. So the output will be an array which will Boolean array which will give true for the cases where the condition is satisfied. So this is useful when using conditionals to just segregate that part of the array. Then this is pretty basic since we are only dealing with 1D arrays. Now moving on to 2-dimensional arrays. So in this what we can do is the star operator, that is the element wise product. That the star will do an element wise product and not the matrix product that you would expect. The matrix product can be achieved by using the @ operator. So this result will be the matrix product of A times B. Another way to do it is using the dot A dot B. So this is an operation included in the NumPy package. It will give the same result. Other functions include the common functions that you use like exponentiation, square root, or adding. All of those are included under the umbrella of universal functions. So what do universal functions do basically is take each element of the array, implement the function onto that element and give an array with the answers, and the array will be of the same size as your input array. Okay, so let's say this was your original array B with the elements 0, 1 and 2. So using an exponent e raised to b function, so it will just give a array, a one-dimensional array with 3 elements which are element wise exponents of this. Similarly for other functions, so here is a list of functions that are provided under the universal functions. So you have the ceiling, diff, floor, in product, mean, median. You can vectorize an array. You can find a trace, transpose. So you can explore all those. Here I have provided the links. I'll be sharing the slides in a while. Now moving on to the more interesting parts. So you can index an array. The first thing is like the normal. Just one index will give you the index I will give you the ith element, and since we are dealing with Python, it will be 0 index. A2 will give the third element. So you get how it's here. Then you can use stuff like this. If you have used MATLAB, you might have seen a similar syntax. So 2:5 will give elements in the range 2 to 5, where the upper limit is exclusive. Okay, so it will include 2, 3, and 4, the third, fourth, and fifth elements here. Then you can also select elements which have a certain difference in the index. So this is the same as 0:6:2, where you will select the elements in the range 0 to 2 with a difference of 2. And then you are setting it to 1000 here. So when you print out this array, you'll see that the elements 0, 2, and 4 are set to 1000. So 0, 2, and 4. Okay. Now let's say you want to reverse the array. So a very easy way to do this would be to just give empty arguments for the first two, that is the start and end. So it will indicate that you're iterating over the entire array, and using a -1 gives a difference of -1 in the indexes. So it basically reverses the array. And for printing, you can just use a normal for loop with iterating over the index. Then you can also create an array using functions. So how do you use that? So the syntax is, you first define a function, then you pass the function as the first argument, then the second argument gives a list of the dimension that you want to use for the function. So phi would indicate that x runs from 0 to 4, that is 5 elements, and 4, that is y runs from 0 to 3. So it will plug in those values and it will create a grid of elements which are obtained after operating on this function. All right. So then accessing two-dimensional array elements is done by using a comma separated list. So B2, 3 will indicate the third row, it is 0 index, and the fourth column. So 23 right here will be the answer. You can use the arguments in the form that we had seen in the one-dimensional arrays. So using 0 to 5 will indicate that you want to check the first fifth rows, and 1 will be the first one will be the second column. Okay, so the second column, and you're checking all the rows. This is equivalent to basically just putting a colon. So this is pretty basic stuff. You can also iterate over the column, and b-1. If you just give a single element, then it will automatically fill the rest of the elements with how much ever is required. Okay, -1 will indicate that the first argument you're putting is -1 and the rest are complete. So -1 would indicate the last row and all the columns. So more of this, you can use the dot dot dot, the 3 dots, to represent that you can put as many colons as you want. So let's say X is a 5-dimensional array, that is, it has 5 axes. So putting an X 1 2 dot 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 indicates that you want the last 3 arguments to be colons. Colons indicate that you want all the elements in that part. Similarly, you can put the dot dot dots before. So you want just the third element in the fifth axis. And similarly for others. So now indexing can also be done using an array of indexes. So you can create an array of indexes like this, and then you can use that index array, and the output will be the elements of the original array A with the indexes as indicated in this array. The dimensional will be same as the indexed array that you're using, as can be seen in the second example here. Then you can reshape an array. The reshape function changes the dimensions of the array to fit whatever arguments you're passing. So np.arange12, this indicates that you want 12 elements. The starting is 0 and the difference is 1. So it will be an array of 0 to 11. And then you're reshaping it into a form factor of 3 by 4. So it has 3 rows and 4 columns. And then you're creating a Boolean array as we discussed earlier. So you can see how it will be created. So we have 0, 1, 2, 3, 4, and the fifth element from here onwards, it will be 2. And then you can pass this argument, the Boolean array, to print only the elements where it is 2. So in this case, it will be the elements which are greater than 4. A similar approach can be used to set the elements. Like if you want to set all the elements above it, let's say they're statistically insignificant, so you can just set them to 0 and move on. Then you can also stack vectors. So you can have vectors like this, and then you can stack them on top of each other to give you a bigger list of vectors. Okay, so before moving on to the linear algebra, I'll execute some of the codes. So let me check the chat box if okay, yeah, I'll share the PPT. Okay, all right, I've put the PPT in the chat box so you can read through it and access the links. Just comprehension. Yes, the arguments that you're passing into creating the arrays, you can use the normal Python list to do that. You can also stack multiple Python lists together as you have stacked the vectors. Okay, so let's try a few basic operations. Okay. Okay. So I'll do those in the terminal itself. So remember, we are in the virtual environment where we have installed the packages. We'll launch a Python shell and let's declare a few arrays. Okay. So A is an np dot. Oh, sorry. First, you have to obviously import the library NumPy as np. So I hope you're familiar with the import statement. So we'll be using the shorthand np for indicating the library NumPy. So we'll create an array, let's say a 2 by 2 array. So let's keep it simple. 1, 2. Alright. Sorry. Sorry. So when you print out A, it will be an array, a two-dimensional array with the elements as shown here. You can also create an array like this. So let's use the linspace command to do. So let's say we want an array in the range 10 to say 40, and we want 4 elements. So when you print out B, it will be an array like this. So now obviously if you want to add and subtract those arrays, we'll need to ensure that they are the same dimensional. So what we'll do is we'll reshape the array. Okay. So instead of this command, what we'll do is we'll do a reshape. The arguments will be, we want a 2 by 2 array. Now you can see that this array will be converted to a 2 by 2. All right. Okay, now let's try some of the basic addition and subtraction functions. So a minus b, so rather b minus a would be. So if you use b minus a, it will do a normal matrix or element wise, it's the same thing, subtraction. If you do b times a, this will do an element wise multiplication. So you can see that 10 times 10, this is 2 times 20, all right. Then let's say we want to do a array multiplication, so we'll use the at the rate operator. So this will multiply the two arrays, and the data type is obviously the larger data type as you would normally expect. So in this case, since we hadn't explicitly given a data type to b, it will assume that it's a float. That is why you can see the dot here, the decimal point here. So when you're multiplying arrays or adding or subtracting them, the more expressive data type will be used. You can do some more interesting stuff by declaring complex arrays. So say we declare a two-dimensional complex array. Okay. So let 2 plus j, 3 plus 2j. I'm just taking random numbers. 4 plus 3j. Alright. Sorry. My bad. What am I doing? Right. You need to pass the data type here as well. Uh, Sorry for that. Is it messing up? Okay, we'll have a look at this later. So just note that you can use complex arrays here as well. Okay, so we'll quickly go through the linear algebra now, and then we'll start with the plotting libraries. Okay. Okay, so linear algebra is supported by the LinALG package, the linear algebra package. So it supports operation like inverse, or finding the eigenvalues or the eigenfunctions associated with a square matrix. Then you can also do the regular @product matrix products. You can calculate the trace, and for a identity matrix you can use np.I, and 2 indicates the dimensions. Then we won't be covering linear algebra in great detail. So yeah, these are some of the functions that are supported. This screenshot is directly taken from the documentation page. So you can see that it supports very advanced functions and can be used as required. So I'll be sharing the links to where you can find those and how to use the syntax for those according to your needs. These are some more of the advanced linear algebra functions. And yeah, these are the resources that you can use. So the official documentation will give you an idea about the syntax required and the usage of various packages inside the library. Another link for Geeks. This will give a tutorial kind of thing. Most of the content we have covered today, but you can go through this. And this is a free open source book. You can use it as a general purpose reference. All right. So, any questions? Okay. Yeah. I think that was the issue. Right. Okay. So before moving on to the plotting libraries, first Abhishek will be doing some interesting stuff with the automation libraries. So handing over now to Abhishek.
Hello. Hi, I'm Abhishek. And I'll be doing OpenCV and Selenium right now. Just give me 2 minutes. I'll set up just. So by the time, what you can do is, if your terminal is open, you can do a pip install OpenCV Python, so that your library is ready. Can anybody confirm if my screen is visible?
Yeah, Abhishek, it's visible.
Okay,
Yeah.
great. Yeah. Okay, so we'll start with OpenCV Python. So OpenCV is mainly a library that involves image processing. So it is designed to solve computer vision problems. It extensively makes use of NumPy that you have just learned, because the images are stored as NumPy arrays. Uh, and as the name suggests, OpenCV, it's an open source library. So if you find a bug or something in the library, you can just go and contribute in their GitHub repository, which is there in this link. I'll share the presentation afterwards. So yeah, this is the installation and the importing of the library. You have to install NumPy and install OpenCV Python, and then import both of them like shown in the code. So I would suggest you to use the virtual environment for installing the packages. Yeah. So basically, what is an image according to a computer? So a computer stores image in any of the color spaces like RGB, BGR, or a black and white gray image, or in HSV or the CMYK form. Uh, when let's consider the RGB one. So in the RGB, it is array that has 3 channels. So one is for only the red color, one is for the green color, and one is for the blue color. And all the pixel, each pixel value is range from 0 to 255. So 0 is the black, and 255 is the white. So that's how it is considered. And for RGB, it's 3 channels with R, G, and B, because you can make any of the colors with combining all 3 colors. So coming on to functions of OpenCV. So this is the most basic function of OpenCV. Hits CV2, so you have to import CV2, and the first function is imread, that is to read a image. So syntax is like this: cv2.imread, and path and a flag. So a path is, you have to give the path where you have stored your image along with the format, that is any PNG or .jpg. And flag, it specifies the way in which image should be read. That is whether you want a RGB image or whether you want a black and white image. So by default, it's cv2.imread color, so it will import it in RGB format by default, and it returns an image that is loaded from the specified file. The second most basic function is the imshow, that is cv2.imshow, and you have to give the window name and image. This function is used to display the image. We'll be executing the code after 3-4 functions. So this function displays the image. Window name is the name of the window that displays the image. So there'll be a window opened, and this will be its name, window name, and image is the image that you have imported using imread, and it does not return anything. It just shows it just displays the image. So if you have processed the image using OpenCV, then you'll have to store it somewhere. So that is when you use cv2.imWrite. This is used for storing the image. First, file name is the parameter, that is the file name. It must include a .jpg or .png while you're saving the image. So it will convert your the array that is there in NumPy array into this image format .jpg or .png. And image here is the image that you are storing. Yeah, so moving on to some functions of OpenCV. This is a add weighted function. This is used if you want to add two images. So first, I think I'll show how this works, and then yeah. If you can see, I'm using virtual environment. Here it's Vn. Yeah, first we'll read this code. This is for importing, like how we saw the imread. First, I'm importing the image using cv2.imread img.jpg. This is the path because the image is in the same directory as the Python file, so it is just cv2.imread and the image name. Now I'm converting it to gray image using cv2.convertColor. Just a minute, this is the other file. Sorry. Yeah, so you wanted to see this file. So first I'm reading the image 1, then I'm reading the image 2, and as shown in the slide, the cv2.add weighted function, I'm using it like this. The weighted sum is it just adds every pixel values with this weighted parameters 0.5 and 0.4, and this 0 is a gamma value, that is amount of light that you want in the image. So it will have the weighted sum cv2.add weighted, and then it will show the weighted image and the input image 1 and input image 2. So we'll execute this. Yes, so if you see, this is a input image 1 and this is the input image 2. You guys are able to see all the windows, right? That are displayed in the screen. Can anyone confirm?
Yes, we can see.
Yeah, so this is the input image 1, this is the input image 2. Both of them have to be of same dimension if you want to add them. And when you add using the weights 0.4 and 0.5, this is the third image that you obtain. So you can create like many such images using this add weighted function, where you can it's basically adding adding the pixel values and giving this final image. Yes, so yeah, so that was add weighted function, image 1, and the weight 1 was the 0.5 for the first image, the second image, then the weight 2 for the second image, and then the gamma value, that was 0 in this case. If I change the gamma value, then it controls the amount of light. Say if I make it 30, say, then save the code. So yeah, there's more light. It appears to be more light, so that as you increase the gamma value, it adds more light to the weighted image. Yeah. So now we'll come to bitwise operations. So you must have learned bitwise operations in C, where if there is a binary number of 8 bits, then if you are there are basically 4 bitwise functions in this one. There's AND, OR, AND, XOR, NOT, and there's OR as well, but it's not there here. So if there's a 8-bit binary number, then every bit is operated along with the corresponding bit of the next image. For cv2.bitwise and all the pixels in the images undergo bitwise operation, and this is how the syntax is. cv2.bitwise and source 1, that is the image 1, source 2 is the image 2, destination is the output array, but you may not add destination here, and the mask is the operation mask. So basically this function is used if you want a certain part of image, like if you just want a left top corner of the image, then the mask will have to be all the ones in that left top corner and all the zeros in the rest of the image. So that is bitwise and. So similarly, bitwise XOR, the parameters are same, but here it's an exclusive OR bitwise operation. Similarly, not, but not, the only difference in not is not operates on only one image. So if a image has all the zeros in its pixel values, it will be converted to 1, and 1 will be converted to zeros every bitwise. So if the images have values from 0 to 255, so they are converted first to the binary, and every bit is operated using this function. Then you obtain the final image. So here is the demonstration. This is the input image 1, that is a square, and the input image 2 is a circle. So when you use AND, this is what you get. So wherever both of them are 255 and 255, it will output 255, because the 255 will have all the ones when converted to a binary image. For XOR, similarly here it's all 255 and 255, and its XOR will give a 0, because for XOR it has to be the both have to be of different types. There is 0, 1, and 1 or 0, then it only outputs true value. Here is a bitwise OR. and this is again bitwise AND. Now we'll see some functions where you can draw something on the image. Coming to the first basic, the most basic thing that you can draw is a line. So this is a syntax cv2.line. Image is the image. Starting point is the x. Starting point is the it's a Cartesian value, x coordinate comma y coordinate, but here it's represented as pixels. So if your image has images of length width 1024 and width 512, then each value in the pixel is 1x and each value in the in the y-axis is 1y. So that is how the coordinates in the images are calculated. So you give a starting point, you give a end point in a similar way as the starting point, and then for the color you can pass a tuple. Tuple is a Python data structure which is represented like this within two parentheses and then the values. So you have to pass a tuple that has three values because it's a BGR image. So it has three channels, one value for blue, one value for green, and one value for R. So 255.00 will be for blue color because it's all blue, and then no green and no red. It's completely blue color. And for thickness, you have to provide thickness in px. So px is the pixel. So how many pixels thick you want the line to be. That is what you have to provide it in providing the thickness. Yeah, so this is how you can draw a line using OpenCV. The second thing which you will need is a circle. You will need this if you are using a face detection or you're detecting any object. Then you have to draw a bounding box or a bounding circle around it. If you're detecting an eye, then you have to draw a circle around it. So for this, the syntax is cv2.circle. First you give the image and the center coordinates in the similar way that I'd shown in the last slide. That is x coordinate comma y coordinate of the using the pixel coordinates, and then the radius of the circle, then the color in same tuple format, and similarly the thickness of the circle in px values. So if you give a thickness of -1, then it will fill the entire circle by the specified color, and it returns the image like this. So this has some finite. This is some very small thickness, and this is the thickness equal to -1, that it fills the entire circle, one on the right. This is also a very important thing, that is the cv2.rectangle, because similarly if you are doing an object detection task, then you have to use a bounding box, draw a bounding box around the objects that you have detected. And parameters are the image point, the start point, end point. Start point and end point, that is basically the diagonal points of a rectangle. Then the color you have to specify in the same format, BGR and a tuple you have to pass. And for thickness, you have to give the rectangle border in pixel values. Similarly, as in the circles, it will thickness of -1 will fill the entire rectangle by the specified color. So yeah, this is how you draw a rectangle using OpenCV. Yeah, so now coming on to a bigger function where, and I will execute this. So this is cv2.cvt color. So sometimes what happens is you import an image in RGB and then you need to convert it in BGR, or you want to convert it in black and white, or you need to basically change the color space of the image. So for that we use cv2.cvt color, and we pass the src. Src is a source, that is image whose color space has to be changed. Second one is the code. It is the color space the conversion code, that is whether you're converting from BGR to RGB or BGR to gray or gray to RGB. And the third, these are the optional parameters, that is the destination output image and the number of channels in the destination image. So 0 means same as the source channel, so you can also manipulate the channels in the image, and it returns an image, and we'll see how this works. I'll be sharing the codes as well. Yeah, so this one is for the color space changing. I am importing the image using imread. And gray is used to convert color, CVT color, IMG, and this is the color code that was mentioned, that is BGR to gray. So it will take a BGR image and convert it into gray image. cv2.imWrite, this should be the name of the image that it stores, and this will be gray. Gray is the name of the image here. So now I'm plotting this using a library matplotlib.pyplot, which will be covered just after this. So I'm doing this because I need to plot two images simultaneously and as a subplot. So plt.subplot 1 to 1 will be an image with one row and two columns. plt.imshow, this is the first image that I'm showing. You can use cv2.imshow as well. This is cv2.convertColor image. I'm converting it BGR to RGB because there's a little glitch here that when you're showing your image using matplotlib.plt, it reads image by default in RGB format and the cv2 reads in BGR format. So that you have to take into consideration, and I'm converting the BGR to RGB just to show the original image. Basically, I'm showing the original image that was there. And for second one is I have converted the gray image on the 6th line. So that I am showing here in the second subplot. Just confirming the screen is visible and the sound is all right, right? Can anyone confirm?
Yes.
Yeah. So yeah, this is the original image and this is the processed image. That is, I've converted this color space from the colored image to a gray image, this black and white image. This will have actually just one channel because it's just 0 to 255. Either 0 is black and 255 is white. Here it has three channels, that is BGR, that is blue, green and red. So these are the two images, and this is how you convert the color space. You can as well convert, if you're not using this, then it will output a BGR image instead of RGB image, and you'll see it will be a quite different image. Yeah, so see here what happened is the blue color was read as a green color by PLT, and green color was read as a blue color, so the image looks quite different. So these are some things that you need to take into account while if you are using like two libraries. You have to read the official documentation and see how the functions are defined. Yeah, so before moving on to that, just a minute. I'll also show this. This is camera video capture. So OpenCV also works for videos. It does not have to be an image. So basically, what happens in this is you first use this cap equal to cv video capture. That means it will capture the video. If you specify a path of any video here, then it will open that video. But if you specify a 0, then it will open your webcam. And secondly, while you have to use a while loop, which an infinite while loop, because a video is basically a set of a, large number of frames. So when you're using this infinite while loop, this is how you read an image. That is cap is this variable cap dot read. Here it actually returns two values, and in which second one is the frame that you require. So this after you use for image. So what I'll do here is cv2.im show frame and then frame. So it will keep rendering every image in the video, and you'll see it as a video is being played. And when you press any key, then it will stop. And then cv2.destroy all windows means after this, all the windows that it has opened. Run this. So yeah, this it now, since I have used for video capture I've used 0, it is opening my webcam and showing whatever it displays. So you can also do some image processing on this image. There's no image processing involved here because it's just I'm just showing the image. So you can also draw something or change the color space. That will do in the one of the tasks. So after I close this, okay, wait, I have to press a key to end it. Yes. So yeah, this is an important one because you usually work with videos rather than just simple images. So yeah. Remember this cv2.video capture 0, and this why this is why we are using an infinite while loop. So another task, this is one of the tasks that can be done using OpenCV. There can actually be a lot of tasks that can be done using OpenCV. What you can do is you can just go to their official documentation if you want other task. This is one task that I'll be showing because there are so many. It is not possible to show in one workshop. So yeah, this is one task, that is any edge detection, in which you detect an edge. I'll just go through the concept in a very basic manner because the Python is the main motive of this workshop. So what happens is, this is a Sobel kernel. A kernel is a matrix. Usually here it's a 3x3 matrix, where these are the -1, 0, and 1 value, -2, 0, 2, -1, 0, and 1. So what happens is, if you convolve this matrix on your image matrix, and by convolving I mean, if your image is consider your image as a 9 pixel by 9 pixel, and if I convolve this matrix on the image, then what will happen is, first 3 rows and it will multiply pixel by pixel on first 3 rows, first 3 columns, add those values, make a new pixel, then move right by 1 pixel, again do the same operation, and it will do it until it reaches all the 9 pixel values, and that's how you get another matrix which is called a gradient matrix. And then you can take edge gradient under root gx square and gy square, that is one along the width and one along the breadth. This is a bit conceptual, so you can read up the concept data. This is just a basic concept of how it detects a edge in an image. So yes, this is the code for edge detection. Maybe first we'll run the code and then I'll explain. So yeah, this is an image of IIT Bombay, and if you see, this is the original image, and this is the image where it has detected all the edges in the image. If you see this yeah, so all the building, all the linings and everything, it is processed. Now I'll show you how is this done here. So first, importing all the libraries like we do in all the codes. Secondly, reading the image using imread. Yeah, so this seventh line, this is the function that we're using here, that is cv2.kenny. So this kenny is used for detecting all the edges in the image, like I've shown here. So kenny edge detection. This is one method of detecting edges. There are other methods as well, which are available in the OpenCV official documentation. So here we are using the kenny edge detection. Yeah, so it's as far as the code is concerned, you have to just write this line edge is equal to cv2.kenny. You have to pass the image and the dimension of the image. Yeah, so further I am processing the image using the bitwise not, because the edges are detected as white and the rest of the image is black. So I have to make the edges black and rest of the image is white. So that's why I'm using a bitwise not. And then this is just plotting the image using PLT. I need to make two subplots. That's why I'm using this PLT dot subplot 1, 2, 1, and 1, 2, 2. This signifies one row, 2 columns, and this is the first subplot. This signifies one row, 2 columns, and the second subplot. So first is the image that was imported, and here the second one is the image, the edges that were obtained. And this is a gray image because the edges are just black and white, so I don't need to use a RGB 3 channels for showing this image, so it's just gray. And plt.xsticks is I wanted to hide this when you are showing an image. I wanted to hide the axis, so I can do this using plt.xsticks is actually used for defining the axis, but here I'm passing no value in the array, so it just it means no axis. And then finally I'm saving the image as edges.png. So yeah, this one is the edge detection. Okay, coming on to the last function of OpenCV. This is color segmentation. So sometimes what happens is you need to capture specific color in an image. For example, if you are running your webcam and you just want to capture the blue color in the entire image, then you use this type of functions. So a range of values is first defined for detecting specific color in the region. Like for instance, I want to detect only blue color in my image. So uh, I'll first go to Google. First, I'll type in color picker for HSV. You will find a lot of color pickers over there. From that, you can specify your color ranges. So this is the least the least threshold for blue color, and this is the maximum threshold for a blue color. So I'm using this is as a lower threshold and this is the upper threshold, and then using this cv2.inRange function. So cv2.inRange function, it only only stores the part of the image that is in this range that we have defined, and then finally we use bitwise end that I'll show in the code to how we obtain the final colored mask.
Hi guys, be patient. The presenter lost his connection. He will join within 5 minutes.
We'll have a 5 to 10 minute break now. We'll continue after that.
Okay, fine.
Yes, I think just a minute. I think we can proceed with the workshop. So that I lost my connection in between, so yeah, I had to take a break, and I'll complete the OpenCV part, the final part that I was showing. That is cv.inRange, which shows image or a video in a particular color range that we specify. So here I'll first import. Just is my screen visible?
No.
Hello. Can anyone confirm if my screen is visible?
Yeah, now it's visible.
Yeah. So this is the last part of the OpenCV that we're doing. First, this is the color detection part. So first I'll import the function. I've imported the functions. It's cv2 as cv and then NumPy. Then I'm again using video capture 0 for my webcam to open up and read the frames. Then the same it's the same while loop, infinite while loop that I'm using here. Then frame equal to cap.read. Then here this is a HSV. I'm again using cvt.convertColor function to convert the BGR image that is obtained using this cap.read to HSV image. So this is the color code for it. Color underspace BGR to HSV. So there are this is shown in the last task. And now I'm defining a lower blue threshold. That is lower blue is np.array 100, 50, and 50. This is for a HSV range. This is not for BGR. I've kind of already converted my image to HSV, so now I have to process it in HSV. This is 100, 50, 50 is the lower threshold, and upper blue threshold is 150, 255, and the 255. So now to only get the blue color, I'm using this mask cv.inRange function. HSV is here it's the name of the image. Then the lower blue and the upper blue, I'm passing the range that I want. So then whatever this will output a mask which only has black and white. That is, and afterwards when I'm using cv.bitwise and what it will do is it will impose that mask on the original frame, this one. And then it will show only the blue color. So we'll run this. There's some sort of lag. Yeah. It is going to open my webcam. Yeah, so this one, the one that you see to the left, uh, this one is the original image, original video that is being read, and this is the final image that detects only the blue color in it. So if you see I'm wearing a blue t-shirt and it is able to mask out blue color if I move my hand. Yeah, so it's doing it in pretty nice manner. So this can be used for a lot of tasks, like if there is some medical image processing. So if there is a color by which you can identify a disease or something, then this can be further optimized. Obviously it has to be improvised. This is just a very basic model, so you can use it for such tasks, or else if there is a heat map or something, then you can extract I mean meaningful information by using such functions. Also, I wanted to show you one another task. This is a bit advanced task because here you are using a trained XML model, so you can actually train different models. Whatever I was showing was just a basic. This is a little bit advanced. You may not exactly understand what exactly is all this, but you just know that tasks like this can be done using OpenCV. So first I'm using the video capture function to import a video which is already stored here in my folder. Then here is a Cascade classifier. There are different types of classifiers used in OpenCV for object detection. This is a HAR Cascade classifier. If you Google it, you'll find the theory and everything behind it. Then here is the same while true, that is the infinite for loop. This has to be used for every video because you have to obtain frames from that video and further process each frame. So this converts it into the gray. Then there's this detect multi-scale function. There are so many different functions used in this. This is a bit advanced code than what we have covered. Then here it draws a rectangle. So if you see, we use all these basic functions here and there. So like I had said, for bounding box we need to use rectangle. So here this is for a bounding box. We are using a rectangle, and then it is showing the video. So what exactly is this task I was talking about? Yeah, so see, this is a CCTV camera, and it is detecting all the cars and all the cars that are moving. So this can be a very important task, if you want to detect if anyone is speeding up, or you for any traffic management. So this is a very useful task. This can be obviously improvised by using some deep learning techniques, some machine learning techniques. But yeah, as a basic task, this is quite good. And yeah, that is it. So we're done with OpenCV part. I think we should move on to other plotting libraries. I'm handing over to Atharva from here.
Okay, so we'll be starting with Matplotlib and PyPlot first. Then we'll move on to a more sophisticated library, Seaborn. So I'll start sharing my screen. Okay, just to confirm, is my screen visible?
Yes.
Yes.
Okay. So Matplotlib is a plotting library in Python, which builds upon the functions of basic Python and NumPy that we had learned earlier. It can be integrated with other object-oriented APIs and GUI toolkits like Tkinter, WX Qt, or GTK+. So this line, the third point, Matplotlib makes easy things easy and hard things possible. This is directly from their official documentation page. What this means is that very complicated graphs can also be done using Matplotlib if you give it sufficient time and effort. For the purpose of this tutorial, we'll be using only the matplotlib.pyplot package, which is relatively simpler to implement and can be used for a wide variety of functions. So this is the basic anatomy of the matplotlib figure. So you can see that you have a title up here, you have the X and Y labels. The main canvas on which you draw is indicated by the figure. You can also have multiple subplots like we were using in the OpenCV. Those will be covered. Then you can have a line plot, the red and blue lines indicated, and you can have markers. Shape of these markers can be changed in case of scatter plots. You can add a legend. Then there are these ticks, that is the scale indication, and this is the overall how a graph will look like once you're finally done with it. Now what pyplot does is it simplifies the process of adding the axis and figure. So you need not explicitly mention the range which you want to plot. It will automatically select it from the data you have given. So we'll jump right on to the pyplot package. So the common shorthand that we use is importing it as PLT. So we import just the pyplot package for now as PLT, and then you simply plot some numbers. So when you're plotting this array, this list 1, 2, 3, 4, what it will assume is, since you have passed only one argument, it will assume the x argument to be evenly spaced indexes of these. So the indexes, since they start from 0, you'll see that the x-axis goes from 0 to 3, and the corresponding y values are plotted from the given. Then the y label can be set as plt.ylabel, and you give the string argument, so it will set the y label. Similarly, an x label can be set. Similarly, you can set a title, and the final plt.show displays the plot. Okay. Then let's say you want to pass 2 arguments, so you can do it with manually adding the 2 arguments like this, and then you can get a kind of graph that you want. So this is the y is equal to x square graph, but it's not quite smooth because we have only taken a limited number of points. We'll improve on this later with the functionality offered by the NumPy package. Now the lines here are pretty simple. The default is a blue line and just the solid line. So all these factors can be changed using a formatting styling argument, a third optional argument, and that argument is similar to what you might have seen in MATLAB. So it's a string containing the following things. The first thing is a color. So you can either use the standard colors using a single letter. So you have red, green, black, blue, K is black and W is white, or you can use the hex string to indicate the color. Then you have the line type. So you can have a solid, dash, dotted, dot dash. There are many. Similarly, in case of a scatter plot, you can also select the markers. So either you want the circle, square, triangle, and so on. Here is an example. So the first thing you're doing is you're importing the package. The import matplotlib.pyplot as plt line is not visible here, but you have to also include that. Then you import the NumPy package, and what you do with the NumPy package is you generate a list of numbers which are spaced in shorter intervals. Like you're generating a list from 0 to 5, where each point is spaced at 0.2. So you'll get a nice, almost continuous kind of graph. So then you plot. You can plot multiple graphs together by adding the arguments. So T is this range. So the first plot is you're plotting a red dashed line for y is equal to x. So yeah, it's almost flat because the scale is such. Then the second you have is the y is equal to x square graph, and you're using a blue and a square, so you can see the points here. Similarly, for y is equal to x cube, you're using a green and triangle. And finally, plot.show. This will only be necessary if you're using either the terminal or an offline IDE to do this. If you're using an interactive shell like Jupyter Notebook or something, you won't need the plot.show. It will automatically be shown. Then you can also do more complicated stuff like plotting the categories. So the same graph can be indicated in terms of a bar or a scatter plot or a line plot. So what you do is you're first declaring the array for the names on the x-axis, the values given on the y-axis, and then the figure size indicates the size you want. So 9:3 is like it's not exactly pixels, it's pixels times some multiplier. So it will create a somewhat horizontal shaped window. Then you have the subplot function. The subplot takes 3 arguments. First is the row number, the number of rows that you want. The second argument is the number of columns, and the third is the plot number among these 3. So the plot number can range from number of rows into 0 to number of rows into number of columns. So in this case, there will be just 3 plots ranging from 1 to 3. Now you might see that there are no commas in the argument. So that is possible only when the product of number of columns and number of rows is less than 10. If it's greater, you have to put the commas to indicate that these are 3 separate arguments. Okay, so once you declare the subplot, now you plot that the figure that you want. So the first you are using a bar plot. So the syntax is just plot.bar, and you pass the 2 arguments, and there are optional arguments. We'll see them later on. Similarly, you can plot scatter plots and just plot. plt.plot will just give a line graph. Now you can view the SUP title, that is a heading that you want inside this, and finally the show. So more on subplots. So here is an example. The first plot you're using is a decaying sinusoid, and the second is just a sinusoid. So in the first case, you're first plotting a line graph indicated by the first three arguments here. No, the fourth, fifth, and sixth argument. The first three indicate the blue dots. All right. Then the second plot is just the cost function. Now these mathematical functions are included as part of the NumPy package, so you can use them directly here. And you can, yeah, these are some general purpose graphs that you might need in your assignments and stuff. Now moving on to the specific kind of graphs. So we'll first look at the bar plot. So in bar, you use all these arguments. The arguments are given here. The main thing is the x and height. These are the compulsory ones. You have to give the labels on the x-axis and the corresponding height. The width will be default, it will be taken to 0.8, or you can specify whatever width you want. This will be useful if you want to plot multiple graphs side by side. So you can change this. The bottom is useful if you want to offset the bar from the bottom by a certain amount. So this will be useful when you want to plot joint bar graphs. And align, this will be useful again when you want to plot joint bar graphs side by side. So the last three are optional. You can use them according to your need. For a basic graph, we'll just use the above two as such. So this is the code that you'll use. So the first thing is you plot.figure. This will create the canvas on which you are going to draw. Then the lengths that we are giving here are the x labels that we want. The students are the heights of those. And then we directly do a plot and bar. So you'll get a bar plot. It's pretty straightforward. And don't forget the plot.show if you're using an offline compiler. Then you have a histogram. So histogram, again, it will be similar. So you have the first two are compulsory. So you have an array x of integers or float values maybe. The bins that you want to categorize into, and the rest are optional arguments. You may look at them and use them according to your need. So we'll just plot a basic histogram here. So we are creating this array of random numbers in the range 0 to 100, and then we're declaring bins. So these bins are 0, 25, 50, 75, 100. So accordingly, you pass it to the plot.hist function, and it will plot your histogram. Finally, you can set the x label, y label, title, and show. Then it also has a contour plot function. So contour can be plotted using a plt.contourf and passing the three arguments, where the three arguments are the x space, y space, and the value in the z. So for this case, what we are using is we are first creating a list of x and y's that we want to use as data points. So it's a list from -3 to 3 of 100 points, both for x and y. And then x comma y, this creates a mesh grid. So basically, these will just be vectors, single dimensional vectors, but you want to use them in a grid to plot them in a contour plot. So the mesh grid function will convert it to a grid, and then you use the function z on this grid to get the value. And now you have these three two-dimensional matrices which you can use to plot the contour. The plot.color bar indicates the values that this contour plot takes. It will add a color bar. and then the usual title, y label, and show. This is slightly more interesting, a QR plot. This can be used to plot things like magnetic fields or electric fields in the 2D space. So the list of parameters is according to the table here. So the first two parameters are the x and y coordinates of the arrow. The next two parameters are the x and y components of the arrow vectors. And the last is the arrow color. The color default it is taken to be black. You can change it. It's an optional argument. So this is how a QR plot looks like. So the first thing you're doing is creating the mesh grid like you did for contour. Similarly, you're creating the uh, Z, the values matrix, and the gradients you're using an np.gradient function, and this 0.2 indicates the interval in which you want to consider the points. So we are using the same intervals here, so it will just be for each point you're considering the gradient, and then you plot the quiver by the plt.quiver function and the arguments according to shown earlier, and then you'll get this graph. So you can see this is like a north pole and a south pole, and the magnetic field lines are going like this. Okay, now on to three-dimensional plotting. This bit is more interesting. Originally, Matplotlib, when it was created, wasn't designed for 2D plotting, but with utilities coming up, 3D plotting is now very commonly used with Matplotlib. Among these, PyPlot can be directly used for plotting 3D plots. The latest version has some basic plots in it. If you want some more complicated plots, you can use the object-oriented approach. The object-oriented approach hasn't been discussed yet, but it's just you have to separately create the figure and the axis and manipulate them accordingly. So it's not much different than PyPlot. You just have to write one or two extra lines of code, and then you can import 3D plots by this mplot 3D toolkit, which is included with the Matplotlib package. So this is a simple example of a 3D line plot. So we are starting with the import statements. You're importing the NumPy and matplotlib.pyplot, and then you're describing this function. Then you're setting the axis to a projection of 3D. If you don't use this, it will just create a 2D plot. So to use that, you have to use a 3D projection, and then the plot with the 3 arguments and the title and show. To get a feel of how this looks, I'll code it. Okay. So here is PyCharm. So you can use any code editor you like, and even you can compile from the terminal, or you can use an IDE like PyCharm to do it all in one. So I'll start with. So you can code along with me to check the results. What are the functions? Okay. 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 So yeah, this is the function. So you're plotting in the range of z goes from 0 to 1, and you're checking for 100 data points, and then you're calculating the x and y values according to this. You're using the 3D projection and you're plotting. Now when you're using the 3D projection, you can move the graph around with your mouse to look at the graph in 3D. All right. So moving on. Then we have the 3D contour plot. The first steps are going to be similar. So you are declaring the similar to the 2D contour plot that we use. So the first thing we are going to do is use the data points x and y. Then we are going to create a mesh grid, and then we are going to declare the function. In this case, we are using square root of x square plus y square, and then you go ahead and plot it. Okay. I'll go ahead and show this also. What to get what? Okay, so we'll go ahead and run this. So this is the 3D contour plot. You can move it around, and if you check it from the very top, it will basically resemble the 2D contour plot for the same function if we draw it. Now you can see that these lines are due to the number of data points that we are selecting. If we increase the number of data points, these lines will the number of lines will increase, and it will become an almost continuous figure. Sorry. So yeah, here it is. So instead of taking 50 points, I'm taking 500. So you can see it pretty much becomes a nice smooth surface. Okay. Next, the wireframe plot. Now this isn't available directly from the PyPlot package, so you will have to use the object-oriented approach. Now what the object-oriented approach does is it will first initiate the figure by using fig, the variable is equal to figure plt.figure. This will create the canvas. Then you plot the axis. So ax are these axes in the 3D projection, and then you use the plot wireframe function on this. Now understand that this function is applied on the axis object, not directly on the plot object. Okay, and you'll get a wireframe I won't show this, but you can see that it's going to be similar. I'm plotting the same function in different formats here, so you can see. The next is a surface plot. So again, the initialization part is same, but instead of the plot wireframe, you just use the plot surface. Then the color map, CMap argument here indicates what kind of color map you want to use. So this particular is given by this argument. And then the edge color, the differentiating color, you want it to be none. So this is how you'll plot the surface graph. And you can see these are the same graphs, all three, but using different methods. Additional learning, you can look at these resources. I have put up the slides. And this is the official documentation. So you can look at all the functions here. I've only described a few. Matplotlib is a big library with many more things to explore. And here are some of the cheat sheets. So this will give a short, brief syntax for most commonly used functions. Okay. Now, if you have any questions, you can ask. I'll check the chat box. Okay. If just confirming, my chat box is being updated, right? There are no questions.
Yes.
Okay. So I guess we'll move on to the more advanced plotting library, Seaborn. All right. So Seaborn. Seaborn is again a Python data visualization library, which is based on Matplotlib. So what it does is it provides a higher level interface for drawing graphs using a Matplotlib. So instead of declaring each of the variables and the axes and figures and subplots, the whole lot, what Seaborn does is it does all these things on its own. You just have to provide it with a data set, and all the integrities of actually operating Matplotlib are handled by this library. And this also has some pre-made themes, so your graph looks much more attractive and presentable, and you can focus on actually analyzing that data rather than working hard to plot it. So we'll start. The shorthand that we use for importing this is SNS. You can use anything, by the way, for this. It's a convention that this is used. Then the data that you're using, it can be entered manually as you're doing for the Matplotlib, but it is usually taken from big data sets. So Seaborn is very useful when you're dealing with larger data sets where Matplotlib cannot very easily do things that this can. You'll see in a while what I'm talking about. The data sets are normally present as pandas data frames. So pandas is another Python library for handling data and statistical analysis. So the loading of the data sets can be done using the functions in the Seaborn library, or you can even use the pandas functions. For the purpose of this tutorial, this is a very basic low level tutorial. Only cover the example data sets that are provided inside the library. So we'll move on. So this is how you start. So you have to first thing use Seaborn as SNS, the import statement. Now this import statement using Matplotlib is only necessary if you are using an offline IDE or editor, because you have to use the plot.show finally. If you are using an interactive shell, you can just skip the Matplotlib import and final show. It will be shown automatically. Now moving on to the actual aspects. So first thing is you can set a theme. So if you either include this or just don't bother with it, it will go to the default theme, which is like you can see here. You can set various themes, those are available. You can check the documentation for those. Then the tips is a data set, is an example data set from the library, which includes the data for the tips given with respect to the total bill at different times. So this would somewhat be a three variables data set, and you have to plot it using 2D graphs. So you use 2D graphs for different times, and then the replot rel plot function. This will do most of your stuff here itself. You can use the same function with varying arguments to make your graphs look however you want. So the first thing you do is you give it the data. Then you describe what you want on the axis. So on the x-axis, you want the total bill. So you put that here. On the y-axis, you want the tip. And the COL is a column. So the column indicates the two separate graphs. So if you had three or four, like say breakfast, brunch, lunch, dinner, so you can just change it in the data set, and they will be plotted one after the other in the similar fashion. Then the hue indicates that what you want to differentiate with the color. So the smoker is the hue that you are indicating. So the smoker is indicated with a blue or orange. Then you're also indicating a style. So the style of the markers will also be changed. So you are seeing a dot here and a cross here. And then the size, and you're using the size data. So the size can be adjusted. It will automatically detect the size. If the number is larger, it will automatically allot it a bigger size. And that's just it. You don't have to manually change you don't have to manually process the data and put it into the correct positions as you would have to do it in case of Matplotlib, and it will come out with this nice looking graph. So you can see that the hue, so there are different colors. There are also different markers in case of style, and the size is different for the dots as well. So this is how a basic plot will look like. Now we can move on to more kinds of plots. So this is another data library, data set present in the library. So you use the same function rel plot, and only thing you change is the kind. The kind argument indicates what kind of a graph you want. You don't have to change the function. You don't have to change anything else. You just simply use the line argument. And again, the same argument as you had, the x, y, the column, the hue, size, style, and what this does, this last line, is indicate if you want the scale should be the same for both or not. So if you had a true parameter here, what it will do is align the scale for both. So you can see that the total scale ranges from like minus 600 to 700. So what it will do is it will shift the graphs accordingly. But since we are giving it false, it will automatically adjust according to what scale you want to use for each particular graph. And finally, the plot.show. Again, repeating, this won't be necessary in an interactive shell, but you need it for offline editors. Now you can also use it for some more interesting things like statistical estimation. So what you do is, this is another function, line plot. So as the name suggests, it's a plot of the line. So the data you're giving is just the number of flights given in a particular the the data is the flight data set, and the data contains the number of passengers traveling in a particular year. So what you do is the X is the year, Y is number of passengers, and the U is the color indicating the month. So when you're passing this, the different months, and the legend is automatically included, just to point out. You would have to include the legend separately by using a plt.legend in case of only Matplotlib. Okay, so yeah, the legend is included, and you can see this separate plot. Now, say you want to view it statistically, like you just want to view the average number and 95% confidence range. So you just skip this U parameter. What it will automatically do is it will understand that you don't want the individual lines, but you want an aggregate figure indicating the data from all those lines. So what it will do is it will indicate the mean given by the dark blue line. Light blue region will indicate the 95% confidence interval. So this is how you can use it for statistically representing the same data set. Now you can also use it for linear regression. So the first that we had seen for the tip versus total bill. So you can also fit a linear regression model through this by using the LMplot function. So the arguments are going to be similar. First you pass the data and what you want on the axis. That's it. You don't need to bother about anything else. And the U. And the LMplot will automatically fit a linear regression model. Now you can see that here we haven't included the style for the smoker or the sizes. So all the plots will be dots and of the same size. So you can include those for more complicated, more good looking structures and figures. Then you can also have a distributional analysis. Like this was just your plotting the points as you obtained them, and you're fitting a model through them. But in this, what you're doing is you're statistically counting the number of points. So the function you use is displot. So the first thing you do is the data, pass the data, then whatever you want on the x-axis. In this, understand that the y-axis will automatically be the number of such cases because you're plotting a histogram kind of thing. So then you indicate a column, and the Kde true will plot this will plot the peaks line. Set how do I put it? Graph of the overall distribution. So you can see that it's peaking at certain values for both the graphs. It will just fit this automatically. You don't need to manually consider what you're plotting. Then same data set you can go ahead and indicate in a categorical plot. So the function used is cat plot, and the kind can be changed. You can either use a box diagram or a violin diagram as we have done here. So we'll just put the kind, we'll just change the kind parameter. Not putting it will give a box diagram. Putting a violin will give a violin diagram. And you indicate the day here and the total bill, and the hue will indicate smoker, and the split will just form this nice structure around the data set that you want. If you put this to false, it will just give the data points without the envelope in which it is included. So this is how categorical plots are done with the cat plot function. Now multivariate data sets can also be easily handled by using the joint plot function. So in this you're using the data set penguins, again an example data set, by loading this data set. So penguins here is the variable name, and here it's the data set name. Then the SNS, the shorthand, and joint plot function. Again, the parameters are the arguments are going to be same. The only thing you change is the function and the kind. The data you can put in the same way. So it eases your effort basically. So you put in the data, that is this data set, then the flipper length and bill length, and you have to indicate the u of species. So you can see that this is this kind of forms a classification model. So it can be visualized in terms of the probability densities in the graphs given here and here with respect to the flipper length and bill length. So now you can go ahead and do more interesting things. This was only indicating bill length and flipper length, just two variables. Now we can go ahead and include more variables. So in total, this data set has 4 variables. So what the pair plot will do is it will plot all the variables that it encounters, and the hue species indicates the color. So this is a complicated graph that would take much more time if you had to do it with Matplotlib. You have to indicate each individual graph and how you want it and what variables you want. But C1 eases that effort. So this will give the diagonal elements will give the probability densities. This will give the space classifying distribution. Now you can go ahead and fit some classification models too. This is an even more complicated function. So what you're doing is you are using a scatter plot and you are using this frame on to be true. Is it visible or is it too small? Okay, I guess it's not visible clearly. I'll zoom
Yes,
in.
it's not visible.
Yeah.
Code is not visible.
Okay. Okay, so I guess it's visible now. Okay, so this is an even more complex function. The pair grid function is what you're using. So I won't go into the exact specifics of this. This all depends on how you want to use the library. So this session is just meant to give you an insight as to how various libraries can help you do your job very efficiently. So again, the function you use here is pair grid. So you put the data set in same. You indicate the u and you indicate the corner. Corner indicates that you want just the lower corner that you have. So the g dot map lower. So this pair grid that you're using, the lower grid, you indicate it with a Kde plot. A Kde plot is basically this the scatters that you have and classification model fitted on those, and various levels of those classification models. So you're using 5 levels, so that will indicate the number of lines, the number of plots that you see, and the color again you can read the documentation for what color scheme it uses. I guess this is just black. Then yeah, the scatter plot, then you plot it with the marker plus. You can change this any way you want. Then along the diagonals, you are using a hist plot. There is a histogram, and the element is a step. You can use either step or for continuous, it's something different. And the line width, how wide you want it. You'll see similar arguments were there in the Matplotlib bar plot package and histogram package. Then the KD is, as we saw earlier, the envelope giving the distribution. And then the legend. So since you're using this, you'll need to specify that you want to add a legend, but it's just this much you can add and you want it to inside the frame. And finally the legend box where you want it, you indicate it, and that will just plot a nice figure and ease your job of plotting all those figures separately, and that's just it. I mean, you can explore all these things further. There are links to the resources in this PPT that I've shared. Yeah, so here are the links. So tutorials point has a very nice tutorial in more depth. So I covered just the basic functions. This will give you a more detailed explanation. Then the seaborn.pydata.org. This is the official documentation website. It also has a tutorial for using the various functions. So you can have a look at it. And again, the thing is, there are many things to cover, and those can't be covered in the limited time that we have. So we'll just leave it at the basics, and whatever you need, you can always refer to this their official website. Okay, so that's it in case of Seaborn. I'll check for questions. What is the full form of REL plot? I'm not aware. You can check the official documentation. It will be there. I'll show you how the official documentation looks like. So I'll go ahead and so this is how the official documentation is. You can check all the tutorials for various types that you want. You have relational, distribution, categorical, regression. So yeah, these are the kind of plots that you can plot. So this is in much more depth and much more complicated plot. So you can have a look at it. So let's see. So if you search, you can check the functions here. So it will give what all parameters it can accept and how it is designed, and the description of parameters and examples of how you can do it. So yeah, you can refer to this. This is a very good resource, very well documented library. And okay, yeah, any more questions? Okay, if there are none, we can move on with the further parts of Selenium by Abhishek. So that's all from my side. Thank you for listening, and hope you have learned about these libraries and will be able to implement them. Okay, Abhishek, you're ready to take over?
Yeah, sure.
Okay.
Hello, is my screen visible?
No, it is not visible.
Yeah. Is it visible now?
Actually, I think your screen is not shared.
I've shared my screen. Just a minute. It should be visible now. Is it still not visible?
No.
Okay. Just let me know if it is visible. I'm just trying.
No, it is not visible.
I'll leave in.
Yeah, now it's visible.
Now it's visible. Okay, nice. Uh, So first we'll do a bit of SciPy library, which is a continuation to the what Atharva has done for Matplotlib and Seaborn. So SciPy is it's an open source library mainly used for solving mathematical or scientific engineering or technical problems, and it provides a very user friendly and efficient numerical routes for various types of like numerical integration, interpolation, and basically most of the mathematical functions that we use. It allows us to manipulate data and visualize the data using a wide range of high-level Python commands. And by high level, I mean why Python is called a high-level language. So you don't have to really write a lot. There are like functions defined for most of the tasks. Yeah, this is some additional information on the library. It contains like various sub packages to solve issue related to scientific computation. Like if you see the sub packages of SciPy, there are different sub packages like for input output. For special functions, there's different sub package for linear algebra, for interpolation and optimization and statistics. So these are the different sub packages of SciPy, just like how Matplotlib.pyplot is one package for plotting of the 2D functions. So here are some more for integrations. SciPy.integrate, then Fourier transform, signal processing, image manipulation. It is not possible to cover everything in this, but I'll tell you how to look for the official documentation in case you need you need to use any one of them. So this is how you import the library into your code from SciPy import linear algebra or this optimize. These are the sub packages. So yeah, these are some further discussion. File input. This is the first one, that is input output package. Here is the code just to print a matrix. So first you have to import NumPy, because matrix is an it's a 2D array, and from SciPy import IO as SIO. You can use any alias, but this is what is generally used, SIO. Array equal to np.once. So this will form a 4x4 matrix of just the value 1. The floating point value 1 dot. SIO dot save mat, it is saving this matrix, and then data SIO dot load mat, that it will load this this matrix that it has saved here, SciPy.saved, and then this is just a print statement. I think this was implemented in Google Colab, so that's why it was just data and AR. You can add a print statement to this and then data and AR. Yeah, just like this. So yes, this is it. Then let's look at some special functions. So this is basically defined for numerous special functions of mathematics and physics. Some include like this array, elliptical, Bessel, gamma functions, beta functions, hypergeometric, parabolic. So a lot of them are there into this. We'll do the very basic part. Special function, import CBRT. This is for finding the cube root. Then you have to pass an array, a list of numbers of whose cube roots you want, and CB equal to CBRT, and then you have the cube roots. Similarly for permutations and combinations. So basically for permutations we use SciPy.special.perm, and here it should be R, like how it is defined in the formula. So now we want to find permutation of 11 and 3. That is that is 11p3. According to the formula, it should be 11 factorial upon 11 minus 3 factorial. But in Python, we do it like this. First, from SciPy.special import perm. Then we use the function 11, 3, and exact equal to true. This means that when we if there is a array that you have provided and it has floating points, then the final answer will not be a floating point. I mean, if you don't use exact equal to true, it will output a floating point that is 990.0. But if you use exact equal to true, it will output an integer. It is not a big difference, but yeah, according to the programming language and the format, it is quite different. So yeah, we usually use this because we want an integer number. Similarly for combinations, there is for this function com, and it's just similar from SciPy.special import com, combination of 15, 4, exact equal to true, and this is what it outputs. These were very simple tasks that can be done with SciPy. This is one complex task. This is Bessel function of real order. So Bessel not really getting into the theory because that is not the motivation of this workshop. So this is just a basic look over. Bessel function is a family of solutions of Bessel's differential equation. They are solutions of this differential equation, and among other uses, these functions arise in wave propagation problems. So basically what we'll get is a wave function. We're able to plot a wave function. So here is an example of a circular drum head anchored at the edge. That is a bit complicated code. So I'll also tell you how to look at the code if you don't understand it, how to understand it. So here we have imported a couple of libraries from SciPy. We have imported the special. This we know is NumPy, Matplotlib.pyplot. This is one new library that is for 3D plotting 3D axis. It's MPL toolkits.mplot3d. So if you want to understand it, and like if some library is new to you, what you have to just do is just copy the code, open a tab, and .axis 3D, and when you do this, you'll find the official documentation. It is one sub library of Matplotlib, and here is an official documentation. So you can, this is user readable. So yeah, so that's how you'll look up to something which you don't understand in the code. So there are so many functions here. This is we have defined a function here. Yeah. So this return should be above, but due to the size of the PDF, it has gone below. Never mind. First, we define k0 equal to special.jn zeros. This is the function for using this basal function. Then we take theta is np.r r underscore. This will give give a list of 0 to 2 pi with 50j, the spacing of 50j, and then similarly the radius, we define x, y, z, the 3 arrays for plotting, and then afterwards is just the plot, plt.figure. Then we use the axis 3D that we have imported from this MPL toolkits. And then we set labels to x-axis, y-axis. Here is again plotting this ax.plot surface function. So if you don't know what this function is, just have to copy and just paste it. So yes, here you get all the documentation. There are some unofficial documentations as well, the tutorials and everything, but you can always refer the official documentation. So yeah, and afterwards you get this plot. So yeah, this is one complicated code a little bit. And these are how we define the axis, x-axis, y-axis, and z-axis. So let's move on to the Selenium, another interesting library. Just confirming once if I'm audible and the screen is visible, if anyone can confirm.
Yes.
Yeah. So the Selenium Python. So Selenium is an open source and a portable automated software testing tool. It is mainly used for testing web applications. Mainly if your backend is in Python, then you mainly use Selenium. Selenium is there for I think Java as well and other languages. But here we are focusing on Python, and we're not using for testing right now. We'll do it for some other. We're doing it for some other tasks. So it has capabilities to operate across different browsers and operating systems. And it is not just one tool, but there are 4 different sub tools of Selenium. That is Selenium IDE, RC, WebDriver, and Grid. We'll be looking into the Selenium WebDriver in this workshop. So why Selenium? Why like Selenium? Because it has a lot of competitors, and why we choose Selenium? It's mainly because it's open source and portable. It's easier to understand and implement. I mean the syntax is pretty much easy. It also it also is time efficient. It reduces test execution time, and it also supports parallel computing. So that is one more thing that's why Selenium is so famous. So these are other reasons why Selenium is better than the other ones. It supports multiple operating systems, multiple browsers. So for installation and importing, this is a bit complicated task if you are first time using it. So I'll share this link on the chat box. So you have to actually install a driver for this. This is for Google Chrome, but there are drivers available for other browsers as well and other operating systems. You can just Google Chrome. You can just Google Selenium driver for Selenium Python, and you will find a driver for your appropriate operating system. I'll share the slides with you. So first we'll go through everything, and then you can implement this because it's already getting late. So yeah, so this is how we imported pip install Selenium, and then from in the code we use from Selenium import WebDriver. This F should be not capital, should be small. And also one more thing while using Selenium is please remove any USB device while using WebDriver because it can create some issues. So yeah, this is the most basic code to navigate to a link. We are using it for web scraping, that is getting the data from websites. So first, navigating to links, this is the most basic code. First we import Selenium, the WebDriver from Selenium. Then driver equal, this is how we create the WebDriver object, driver equal to WebDriver.chrome, and then driver.get, and this is the website that we want. I'll run this and show. So is the code visible?
Yes, it is visible.
Yeah. So this is a very basic code. From Selenium we import WebDriver. These options I have added because there were some security issues with the Chrome that sometimes you get a certificate.
Abhishek, can you increase the font size?
Okay. Font size. Does anyone have any idea how to increase the font size? I'm not able to
Yeah,
get
maybe
it.
you can go to edit and preference maybe.
Yeah. Maybe it. Just a minute.
Just once say in view, there is option.
Where?
In view.
Okay.
View. Appearance.
Okay. Appearance.
Zoom. There is
Okay.
option of zoom into out.
Yeah. Now is it fine?
Yes, sir.
Okay. So this this line 8, 9, and 10, this is added just because sometimes Chrome gives a privacy error that because it's an automated browser, then Chrome is pretty much secured, so that it can give error, and that's why we are adding this argument. You just copy. You don't have to remember anything. I just googled how to handle this privacy error. I just typed there, and I got this course on Stack Overflow. So you have to add this. And then from here driver equal to WebDriver.chrome, and here I'm adding the part to my Selenium Chrome driver. In the PPT, the first this one, the first line that said driver for Chrome, you have to first download it and put it in some location which you can access, and from there you have to pass the location to the Chrome driver, and these options as another parameter. And then driver.get, I'm going to Google first, google.com. So
So yes, it is able to open this google.com, and now we'll see how we can access the elements on the web page. Okay. So, yeah. Okay, so I'll have to first explain a little bit about the website. So if this is google.com, what you can do is you can right click and there'll be an inspect option. So you have to click this inspect option and you'll see this in the element section, you'll see this code. This is the HTML code of what is being rendered currently. So if this is just basic HTML code that is using divs and using divs, header tags, styles. So if I want to access a particular element, for example, this is an input element, this where I write something. So what you can do is there is this option here. This is for Chrome, I'm telling. For other browsers, there are different ways, but this inspect option is there for almost all developer suitable browsers. Then I'll go here. I want this input option. I'll click on this, and then I'll get this code at the right, which is corresponding to this in this search bar on the web page. And inside this is called the input tag, which is opened like this, and it is closed at the end. And within it are this different classes, then styles, and there are some, yeah, these are basically styles and classes and the title. So for this input this input element, there is a class, this glfyf, what you see here, and these are different things said by Google, right? So similarly, this is there for all websites. So such HTML code will be there for any website. Okay, yeah. So if this is an input element, this is a sample input element where type is equal to text, name is password, and the PASSWD, and ID is PASSWD-ID. So this is a very simple input element. Then how can you access that element? So there are different functions in the Selenium. This element equal to driver.find element by ID. This is very user readable and it's understood by its name. Find element by ID. So this should be the ID and it will find this input element. Similarly, for if you want to find it by name, it will find the same element but by name. And then find element by XPath. XPath is usually a path to that particular element. To get this XPath, what you have to do is you have to go to the website. You have to go to this developer tools from elements. Here there's a 3 dots. You have to click that and then copy XPath. So this is how you get XPath of this element. This is usually used if you cannot find a class or a particular ID for that element, but it can create problem if the HTML code is changed a bit, if the structure is changed a bit, if there is a div added or any other element added, it can create some problems. That's why we usually use class and IDs. So similarly, there are some more functions like link by the link text. Link text is if there is some clickable link, like here this Hindi and all these languages are clickable links, right? So what you can do is you can just go to this, and here you'll find this A tag. A tag is anchor tag, and it is for these are clickable elements. So if you type Hindi in if you want to find this element of that said Hindi in that, so you have to pass that Hindi here, the link text. Similarly, there's partial link text. If you want, if you know only a partial link text of a particular of an entire link, then you have to pass it here. Tag name is the anchor tag, that is the A tag, and the input tag that I had shown. You can find by that as well. Also, you can find by class name, also by Css Selector. Css Selector is basically all the styles that were used. And in case there are multiple elements, you have to just replace this find element by link text or find element by tag name by find elements by tag name. So just a plural of it. And you'll get an array of all the elements. So what if you want to send some text, like if you find an input element and if you want to write it in automatic way, so what you do is element dot send keys, and whatever text you want you can send. If you want to simulate a key, the key on your keyboard, like by automatic manner, then you can do element send keys. Here this is a text and comma, this should be a parameter. Keys dot arrow down, there are keys dot arrow up as well. We can also use action chains. We'll be using action chains for this. So coming on to action chains, it is a way to automate low level interactions, such as if you want to move your mouse, if you want to hover somewhere, or you have to click a button or key press, then you have to use this action. You can use this action change. So this is how you create this action chains from selenium.webdriver.common.action chains, import action chains. This is how you import it. Then these are the comments, create action chains. This is the code, action equal to action chains driver. Here we are assuming that we have already defined the Selenium WebDriver. And then in this task we are double clicking an element. So if we have found an element and that we want to double click, you do this action dot double click, and then for performing this entire set of tasks you just do action dot perform. So I'll show this here. Yeah, so here the initial part is the same till driver.get. Then element, this is another website. It is meant for web scraping. There are some websites which are used for just testing how your web scraping codes work. Then element equal to driver.find by link text. There is a link text of computers in the website, and then I'm defining here this action change driver, and I'm clicking it, and this is action.perform. That is a code which I'll run now. So you'll see yourself how you can automatically click an element in a website. So this is opening the website first. You can see computer to the left, computers, and it is automatically clicking that. So yeah, it has done its task to automatically click these computers. Moving on, these are some more action chains function. You can click an element, you can click and hold the element, you can context click, or you can double click. There are different action chain functions. Again, for if you don't understand anything, you can just type Selenium action chains documentation. Yes, here it is. I'll close this one. Yeah. So here you have all the send keys, the reset actions. These are different action, some more functions to the action key, the key down, the key up that was shown. Also the click and hold, context click. So whenever you want any such function, you can just Google the library and you'll find its official documentation. Like all the libraries must have an official documentation, and that's how you use the code directly from those libraries. So yeah, news fetching scraper. Okay, so now what we'll do is we'll do a very basic news scraper, which will get all the headlines present in Google News. So first we'll do it manually. So what you can do is google.com. You can type today's news. Go to this news section, and here you get all this news, right? So you want to automate this task. You want to get all these headlines by just automating it. So what you can do is, this is the same code till driver.get. Here driver.get, I'm directly going to google.com and search equal to today, this search question mark q equal to today's news. You can also go to google.com, then choose the input element, type today's.com in that, and then Google click. But this is just how basic syntax, how Google search works. Like if you see here, if you search something news, then yeah, here, so yeah, here it is. Till this part, it's just google.com bar search question mark q equal to news. So yeah, we'll do the same, but by automating the task. What we're basically doing is we are going to this website website and putting the value today's news. Then we are we are finding an element by linked text that says news. That is it went again by the news. That is this element that I clicked just now. This linked text we are finding. This is a clickable element. So we are finding that. But we're finding it with the linked text news. We are defining an action chains driver, then clicking the element, and it is performing the task. So after you perform that task, all the news is visible. If you see, you get all this article cards, and from that your from driver.find elements by class name GIF. So this is a class name that each header tag in this article have. How you can know this? Right click, inspect, select this, go to this header, and yeah, here you have. So if you can see that this is a selected element, the one which has a blue background, it's div class equal to GIF and some another class, but you just need one class. So a one common class that every link article will have. So when there's a space in between class, it means two different classes. There can be 3, 4, as many different classes for a particular element as you want. So now just to check if the rest the other elements also have the same tag. So here it is. I've selected this one now, and yes, it's GIF. So all the header tags have this particular class. So I can fairly use this to get all the headlines of the news. Then it's just manipulating the news. You can make JSON objects and whatnot. You can do whatever you want with the news. Here this is new. I'm forming a list by using element.text. So this elements will give an array of different Selenium objects, and then you have to access different things from that element. Like you can access its link, you can access its text, you can access various things. So I just want the text of the headline. I just want the headline. That's why I'm using element.text for element in elements. So this is a for loop which can be written in one line. You can also write for element in elements, news.append element.text, but this is a simpler way of doing it. Then for item in news, I'm just printing that item. So I'll put on my camera just to make sure that I'm not touching my keyboard. Yeah. going to my terminal. Yeah. So I'm not touching my keyboard. It's everything is happening on its own. Whatever you're seeing on the screen, it has gone to today's news. Now it will go to the news. And now if I open the terminal, I'll open the terminal. And yes, here it is. You have all the news headlines which are there on this first page. I'll zoom in. Yeah. So this is what I've marked in blue. These are the headlines. School reopening, the Myntra post, and yeah, different things. Yeah, this headline: school reopening, the Myntra forced, all these headlines.
Hello? Hello, Abhishek, are you there?
Hello?
Hello?
Yeah, screen is visible, right? Okay, I just lost my
Yes.
connection for. So that was it from my side. This is what is just a basic overview of all the libraries and what all you can do with Python. This was not really meant to like teach exact libraries and exact syntax and exact functions, but to just give an overview of what all you can do with Python. So the main thing you should take away is that you should know what you can do with Python. You should be able to Google write things and find proper links, read official documentation. That is what is important because they keep changing from time to time. So there's no point in really rote learning every function or every syntax. So I think that is it from my side. Thank you all for attending this event. Does anyone have any doubts? Okay, Atharva or Priyanshu, or Srikant, do you want to say anything?
Hey, hi, Rutura here.
Yeah, hi.
Yeah, in the web scraping stuff, like I did not understand what the class was actually.
Okay, so this is a web. This is a little web development is involved in this. So when you so I'll just explain you very basic. Screen is visible, right? Okay. So if you go to any website, then website has different elements. If you see, here is this Gmail, images, Google, and this different elements. So every element, everything is coded, right? So if you see the HTML code of this, it is a proper hierarchical structure. Like first is the body tag. First is the body tag, and then inside the body there's a div. Div is a division that is just a chunk, the chunk of code, and which renders an element. This div, and as you come down, there are different divs And for this div, this small section is defined inside this div. Then there's a style, there's div, there's a form. Form is mainly because for just for submitting or yeah, this is a basic form tag. And like here it's a div tag or style tag, and in this elements need some like identification. Like if you are in a code, you're writing a code, then how would you understand that this particular element is meant for doing this? So that's why we define classes for different elements. Like if you had seen the articles, all the article headers had a similar class. So that HTML element, if it has a class of whatever was there in that, then we know that it is an article. It is an article header, and this is also useful for styling the elements. It is also useful for making it interactive. So this is a bit of web development involved here, because we are scraping websites. So yeah, that's it.
Okay, thanks.
Hello. Any of you have any
Yeah.
doubts, you can ask here. And if you have any doubts in coming sequences, you can mail to us. You can check our website WnCC, which is a coding club of IIT Bombay. And if you have any queries, you can ask it here present.
I'll just share the link to this PPTs. So this is the drive link for the OpenCV and OpenCV Selenium and SciPy presentations. Also, someone was asking regarding the class element in the web development. So we already have resources, the WnCC resources for them. I'll share the link. So in summers, last summers we had conducted these 3 workshops on Python, Python web development and machine learning. So you can refer this. Sharing the link in the chat box. Yeah. Also, you can, if you have doubts or anything, you can ping any of the conveners, or anything you want to discuss regarding coding or web development or ML, anything, you can ping us.
Okay, guys, if there are no any doubts, we can close the meet. And I would like to thank everyone to attend this meet.